Hey guys, this is Vignesh from Brevity. Today we're going to see an amazing application of two-pointer algorithm called Dutch flag partitioning algorithm on a lead code problem called sort colors. Let's get started. In the previous video, Robin explained how we're going to... What? You haven't seen that video yet? You know it's perfect, right? I highly recommend you to go and watch it first to get a good grasp of what we are going to code in this video. Here's a rapid recollection. Consider this a visual representation of the array from 0 to n-1. We'll be using 3 pointers, begin, cur and end. Cur is more of an iteration variable, hence the 2 extra pointers are begin and end. The red section from 0 to begin will contain all the zeros. The white section contains all the ones. The grey area contains all the unvisited numbers and unsorted segment. From end till n-1 will contain all the 2's. So as cur moves from 0 to n-1, depending upon if it is a 0, 1 or 2, it will put it in one of the other 3 sections until this grey area vanishes and becomes 0. That is a very basic gist of this algorithm. For a more detailed explanation, watch the video in the description by Robin. Done? Okay, let's get started with the coding. To begin with, we'll need 2 pointers. Begin, which will hold the first section, and end, which will hold the last section that contains all 2's. Now, we'll also need an iterable, which will start from 0 and go till end. Hence, now, nums of cur is the current value that we'll encounter while moving from 0 to end. What if it is a 1? If it is a 1, it belongs to the white section. So it is right exactly where it should be present. Hence, we'll just move on. Else if we encounter a value which is 0, then it should be moved to the start of the array. Hence, what we'll be doing is we'll swap it. Now the current element will be replaced with whatever is present at begin. Now we can move both the pointers ahead. The only other case which is if the encountered element is a 2, because it can be 0, 1 or 2, hence we use the else condition. Now what we'll do is we'll push it to the last section which contains all 2's, which is represented by this. Now we are swapping the current element with the end of the list, and then move the end pointer towards the left. Let's see if it works. As you can see, it works. Step 2. Check for if there is any edge conditions. What if the size of the list is 0? In such a case, end will represent -1 and cur will be 0. 0 is not less than or equal to -1. Hence, this loop will not run at all. If the list is empty, then it is already sorted. Therefore, one edge case has been solved. What if it had only one element? In which case, end will contain the value of 1 minus 1, 0. 0 is less than or equal to 0. Hence, this part will run, but if it is a 1, we'll just move ahead, nothing. If it is a 0, we'll be swapping begin, which points 0. So it will be swapping it with itself. It will be running for only one value. When current is equal to 0, it will be swapping it with itself in both of these two cases. Hence, that is also one edge case which has been solved. This code very well takes care of all of it. That concludes step 2. Step 3. Debug. If we have seen any errors until now, we would have performed the debugging part right now. But since I already know all of it, there is no purpose for it. Step 4. Optimization. We can use post increment to make this code look a lot nicer. It goes something like this. It's the exact same code, but looks a lot more cleaner now. It's still functional. As you can see, we've done a little bit of optimization using C++ specific code. This works because of the way postfix operators work. That is, when nums of begin is being evaluated, it will return the value that begin is currently holding. But once that value has been obtained, begin will be incremented. The same goes for current also. When nums of current is being checked, that is being evaluated, current will return what value it's currently holding. But after it has been evaluated, it will be incremented. It is basically the same code that we've written before, except using post incrementation process. The same goes for post decrementation process of end also. While evaluating, it will return nums of end with the end value that it currently contains. For example, if it contains 5, the nums of 5 will be returned. But after it has been evaluated, instantly it will be decremented to 4. So nums of 5, and when you check for what the value end holds, it will be 4. That concludes the section of optimization. Step 5. Calculation of time complexity. Here the worst case occurs when the array consists exclusively of zeros, ones or twos, in which case the current will move from 0 to n-1. Hence it is a one-pass linear algorithm with O of n time complexity. And as for space complexity, we don't have any extra storage except the 2 pointers or 2 variables. Hence it has constant space complexity. Thank you so much for watching. I hope you enjoyed it. Now I'll stare at you until you comment genocide on subscribe and like buttons. Share it with your friends too.
Say what?
Bye.